Welcome to the course Business Analytics and Data Mining Modeling using R Part 2. So, in previous lecture we started our discussion on time series forecasting, and we started about this first topic, that is understanding time series. So, we talked about time series forecasting and its application for different industries. Then we also understood the difference between time series and cross sectional data, and from that data point of view how time series forecasting and analysis in general is different from cross sectional analysis. So, all those points were also discussed in the previous lecture itself. Then we talked about the technological advances and how that have impacted time series data collection and availability of time series data sets. Then the next point that we started our discussion on was choice of time scale. So, we talked about two important factors that are important in terms of deciding which time scale should be used. So, first one is as per the forecast requirements, as we talked about. If it is for retail firms, and if if we want to forecast sales, then typically if the planning and execution is geared towards year on year basis, then probably we need to forecast the sales for next year. If the planning and execution is dependent, is everything is in the firm is geared towards monthly planning and monthly execution, then probably we need a sales number for each month. So, depending on those requirements also those requirements will also in a way force us to use a particular time scale. However, we can also look at other factors, for example label and sources of noise, because from the analytics point of view it will have a great role in this, because the forecasting power is influenced depending on the label and source of noise, as we talked about in the previous lecture, that if we aggregate data to a coarser level, then probably some of the sources of noise might cancel out. So, that might be helpful in terms of forecasting the time series. So, let us start our discussion on the next point. So, that is about when multiple time series are to be forecasted. So, there are different approaches that could be used when this is the scenario. So, typically if we talk about the business context, there most of the industry, most of the firms, they have they face this kind of scenario. For example, they might have many products, so the companies might be selling many products, and the requirement would be to forecast multiple products at the same time, depending on the kind of products that they are, and sometimes sale of one product might actually affect influence the sale of other products. So, keeping that in mind, also sometimes the requirement is to forecast the multiple time series. So, one approach could be forecast each series individually, or the second approach is using multivariate time series models. So, these are the two approaches. So, let us discuss few more points about these two. So, one is, as we talked about, single series forecasting, where we are looking to forecast each series individually. So, when this kind of approach is going to be suitable, we will discuss this, and we will also compare this with the other approach, that is multivariate time series modeling. So, if we talk about single series forecasting, or specifically forecasting a time series individually, this is the preferred approach, and the main immediate reason is its simplicity, because we can easily apply our analytics expertise in terms of building model, forecasting model for a single time series. It is simpler, and that then each series can model for each of those series can be done individually, and then the results can be interpreted as per the requirement. However, one problem with this kind of approach is that it does not account for the possible relationships between series. So, this is one problem, because we are building forecasting model for each series individually. So, therefore, of course, in that process itself we are not accounting for any interrelationships that could be there between those series. So, as I talked about, some products we might have the forecasting requirement for some products, and sale of one product might influence the sale of other products. So the time series data that we might have for those products, they might have certain relationships as well. So if we are looking to follow this approach, single series forecasting approach, so this might not be accounted. However, at the same time, if these products don't have such relationships, and the time series that are there, they are typically independent, then probably single series forecasting is the best approach that we could have because of its simplicity. So if we compare some of these points which we just discussed to the multivariate time series model scenario. So in this, first thing is we require a higher statistical expertise for estimation and maintenance because of the multivariate nature of this modeling approach. So the whole approach is because of the whole approach is slightly complex. And in this, advantage is that we can directly model the cross correlations between series. So this multivariate time series model approach, it allows us to model these cross correlations. However, because of the complexity of this approach itself, the available techniques, the available models that we have, they typically impose restrictive assumptions on data and cross series structure. So that is one limitation as well. So these are two main approaches that could be used. If we talk about other approaches, so one is the econometric modeling. So econometric modeling could also be used for time series forecasting. So what typically happens is information for one or more series is used as inputs to model the series of interest. So in econometric modeling, so when we are looking to forecast multiple series, so essentially one or more series, we can extract some important information, meaningful information, and use that as input to model the series of interest. So typically these inputs are based on causal relationships. So econometric modeling, as because some of these models they have their theoretical basis, therefore usefulness of the relationship, meaningfulness of the relationship or the causal relationships, that is typically analyzed and taken advantage, and in the time series of interest that is incorporated and forecasting is done. Then there are alternative approaches involving heuristics which can also be used. So using some of the heuristic principle that we observe for our series of interest, so we can use some of those associations between series of interest and the external variables heuristically. So this kind of approach is can also be done, because sometimes we, for example, even for economic activity, for example, if there is an observation that about the boom and bust cycles of world economy, or for that matter even for a country's economy. So if a particular external event happens before or after, or indicating some sort of disturbance in the economic activity as such, then those kind of associations, those kind of external factors can also be used. So this is the approach where alternative approaches involving heuristics, these external factors, external variables, events can also be used to incorporate in time series forecasting. So this brings this brings us to our next discussion point, that is about time series analysis and time series forecasting. So as we have discussed in the previous lecture, that typically two kinds of tasks that we perform in time series context. So one is analysis, which is mainly descriptive in nature, for explanatory purposes, and then the second one is the forecasting. So we are now we are going to discuss some of the differences between what we call time series analysis and time series forecasting. So if we look at time series analysis, as I have talked about, this is mainly explanatory modeling if we look at time series forecasting, it is predictive modeling, because in time series forecasting we are looking to forecast future values of a particular series. So, this is mainly predictive in nature. If we look at time series analysis, we are looking to understand the time series as such, and therefore, it is primarily explanatory modeling. So, as we can see in the next point as well, time series analysis is done to determine the time series components. So, when we are looking to understand a particular time series, it would be better if we are able to find out the time series components. So, seasonal patterns, trends, relations to external factors. So, some of these kind of things if we are able to determine, it is going to be easier for us to analyze the time series. So, this is what typically happens in a time series analysis. If we look at the time series forecasting, it is done to forecast future values of the series, as I talked about. So, we use the time series data itself and other external information that is available. So, in time series forecasting, as the name suggests also, that we are looking to forecast future values of the series using the series data and also external information. However, in time series analysis, main focus is understanding the time series, and determining the time series components is one part of that exercise. So, let us move forward. So, few other comparative points about these two. So, in time series analysis, in the modeling process, typically structural methods are preferred. So, this is, as we have talked about, to either explain associations or causality. So, there the typically statistical method and structural methods. So, they are preferred because of the nature of the analysis that is done. So, if we look at the time series forecasting, typically data driven methods are preferred, and this is despite their black box approach, because we are looking for, our task is to be able to forecast the future values of the series. So, because of this data driven method are typically considered to be better in doing this kind of task. So, they are preferred, and despite their black box approach. However, as I said, in time series analysis, because the modeling is for explanatory reasons, and therefore, structural method and statistical methods, they are preferred, and we are looking to understand the associations and causality. Time series analysis is also retrospective in nature. So, when we are looking to explain something, so that particular event or that particular thing has happened. So, with that consideration, we are looking to analyze it. So, therefore, even the future values can also be used in doing this analysis, because we are not looking to predict or forecast future values, rather we are looking to understand a particular time series. Therefore, mainly it is retrospective in nature, and we can also use future values, because we are looking to understand the series, we are looking to understand the associations and causality and different components. But when we talk about the time series forecasting, it is prospective in nature, and we cannot use future values, because the main task itself is to be able to forecast future values of the series. So, this is also one important difference. So, this was about the time series analysis and time series forecasting. So, let us move forward. So, the next important discussion point is the kind of forecasting methods that we are going to use. So, as I said, the major discussion in this particular module is going to be around time series forecasting. So, next we are going to discuss the types of forecasting methods that are popular in this particular task, time series forecasting task. So, first one is regression based forecasting methods. So, in this regression based models are typically formulated, and then they are used for forecasting time series. So, as we have talked about for this module, that this particular aspect, regression based forecasting method, we are going to cover in the coming coming lectures. The second method is smoothing methods. So, this is though regression based forecasting that we just talked about, this is mainly statistical, these are statistical based approaches, statistical based methods. But if we talk about the smoothing methods, they are typically data driven methods. So, we will discuss these methods also in coming lectures. So, these are the two popular and common approaches for forecasting time series. One is regression based, more of a statistical based approach. The second one is smoothing methods, which is more of a data driven approach. Then of course, there are data mining methods which are sometimes found to be quite useful in forecasting time series. So, data mining methods such as neural networks, they have also been used time series, and nowadays many applications, they are looking to incorporate neural network in their time series forecasting tasks, time series forecasting analytics quite often. And few points about these methods, that these data mining, as we have discussed in previous modules in this course and previous course as well, that typically we use data mining methods to analyze cross sectional data. However, we can use them in time series forecasting as well, and this is quite a regular thing, specifically if we are looking to incorporate external information into the forecast. So, neural network method and other data mining methods are more preferred if we are looking to incorporate, if we are looking to include other external information into the forecast, then these kind of methods are also being used for time series forecasting. So, overall if we look at, these are the three approaches: regression based forecasting methods, which are typically statistical in nature. Then we look at the smoothing methods, which are typically data driven. Then we have the data mining methods such as neural networks. Let us move forward. So, within forecasting methods, there is another approach that can be tried out, so which is combining forecasting methods. So, this is also something that can be done. So, either we can go for regression based method, the statistical kind of method, or smoothing methods or data mining methods. However, we can also use some of these methods from these different approaches, and use this approach, combining forecasting method approach. So, there are two types of approaches within this combining forecasting method. So, first one is what we call multi-level forecasting, and the second one is the ensemble approach. So, we will first start out with the this first approach, that is multi-level forecasting. So, if we talk about the multi-level forecasting, since we are discussing combining methods for forecasting time series. So, and the name of this approach itself, multi-layer forecasting, suggests that we are going to apply different methods at different levels. So, in the first level we use one method to forecast future values of the series, and in the second method we use the another technique to forecast the residual series of the first model that we have done in the first level, and then the results are used to correct the first level forecast. So, we select one method based on certain criteria or certain preference or strength of that particular method to forecast future values of the series. So, this happens in the first level, and in the second level we can use another method which can now the residual series that we have after the first level, that we can again forecast using the second method, and the results then can be used to correct the first level forecast. So, in this way multi-level forecasting approach can also be implemented to forecast a particular time series. So, what is the main idea behind this particular approach, multi-level forecasting approach? So, let us discuss this. So, main idea of this particular approach is to benefit from the specific strengths of different methods to capture different aspects of the series, right. So, different methods could be suitable to analyze or to be able to model different aspects of a particular time series. So, we are looking to, through this approach we are looking to use those strengths. So, first level, if a particular method is suitable for forecasting certain aspect of a time series which is the prominent one given the data of that series, then probably we will use that method there. And then the residual series is going to be there, which will have the remaining aspect of the time series, which could again be forecasted using the second method given the strength of that method. So, in that sense we are trying to combine the strength of two particular methods and doing a multi-level forecasting, so that we are able to improve our forecast. If we look at the overall process of this particular approach, multi-level forecasting, this multi-level analysis can also be applied on cross-sectional data as well. So, the different methods that we have talked about in one module in the previous course, that is supervised learning, and the other module in this course itself, that is unsupervised learning methods. So, there also for certain types of tasks we can again apply two methods which have different strength and capture the different aspects of cross sectional data. So, this approach can also be applied for analyzing cross sectional data in unsupervised and supervised learning methods. So, let us move forward. So, talk about the second approach within the combining forecasting methods. So, the second approach can be called the ensemble approach. So, what we do in this particular approach? So, multiple methods are used to forecast future values of the series. And now, in the second step, results are averaged out to produce the final forecast. So, multiple methods, different methods that we think are going to be good enough to forecast a particular time series. So, we are going to apply those methods to make their own forecast. Then those results of those forecasts are going to be averaged out in some fashion, and the final forecast is going to be produced. So, what is going to be the advantage, what is going to be the benefit? So, the main idea behind this ensemble approach is to produce more robust, accurate and reliable forecast. If we are applying different methods, then they would be as we have talked about in the previous approach also. So, they will have their own strength and weaknesses, but if we use their forecast and average it out, so they might complement in terms of forecast accuracy and in terms of averaging out the cancelling out of noise, different noise level and sources. So, therefore, main idea is to produce more robust, accurate and reliable forecast, and if we are able to select methods which are going to complement each other and the way we do the averaging of results, we can actually improve our final forecast. So, these are the two approaches within combining forecasting methods. So, overall we have discussed four types of main approaches. One is regression based forecasting, the second one is smoothing methods, the third one is applying data mining methods like neural network, and the fourth one is combining forecasting methods, where we have again talked about two main sub approaches. The first one being the multi-level forecasting, and the second one that we just discussed is the ensemble approach. So, these are the overall forecasting methods that are common and popular for time series forecasting. So, let us move forward. So, as we have discussed before in this lecture, that when we talked about the comparison between time series analysis and time series forecasting, that in the time series analysis, determining the time series components is also an important part, because we are looking to understand the time series. However, some of those aspects are important even for time series forecasting. So, let us discuss time series components. So, identifying time series components is typically the first step before applying forecasting methods, because identification of these time series components is typically going to help in the next few steps of time series forecasting. So, typically we do this identification process of time series components, and whatever insights that we get through this process by understanding different components, that is incorporated in the next few steps that we use in our forecasting. So, what are these time series components? So, typically 4 components are there. So, first 3 we have grouped together. So, these are level, trend and seasonality. So, these 3 components, the level of time series, the trend that is there in the time series, and the seasonality part of time series, they in a sense characterize the underlying series that is there. So, these 3 components are more important for us to identify because they characterize the underlying series, and when we talk about the forecasting time series, it is these components if we are able to analyze and implement and model in some fashion, then they are going to give us a good enough forecast. Then the 4th component is actually the noise, which is something that would be the left out. So, something that we cannot explain or account for. So, these are the 4 components. First 3 are the we can say the structural components, the label, trend and seasonality. The another one is the noise. So, let us discuss these components one by one. So, what we mean by label? So, label is average values of the series across periods. So, what are the average values for the entire time series, and if we can visualize the time series in some sub time periods. So, how those average values are being taken for those sub time periods. So, in a sense that would give us the idea about the level of the series. So, which values are actually being taken by the series at an average overall average level. So, that is what we mean by label. So, for example, if we look at the if we follow the news that is there in the for the stock market, the Sensex index or the Nifty index. So, if we look at those numbers, people will in the news channels and other media, they will talk about that Sensex has reached up to this number 9,000, 10,000, 8,000. So, when we anchor our discussion around a particular certain number 10,000, 8,000 or 9,000. So, essentially we are talking about the level of that particular series. So, because the values are going to be around that particular level. So, in a sense that gives us a sense about where that particular series the kind of values that particular series is taking. So, that gives us an idea about the average values. Now, the second component is trend. So, what we mean by this? So, pattern of change in the series from one period to next. So, typically if we look at the in a particular time series, even if we for example, if we look at the stock market performance, share market performance, and we look at the BSE index and how what has been the pattern in the series from one period to the next. So, this pattern actually reflects the presence of a trend in the series, and so typically for example, if there is a linear trend, so on a longer time horizon, on a longer time period, we would see that the time series is increasing linearly in fashion. So, there are going to be swings and cycles in a shorter time period. However, if we take a long term perspective, then we would see we might be seeing a linearly increasing trend. For example, India's GDP numbers, if we plot them, if we take the GDP numbers from 80s to till now, and if we plot them, then we would see that we might see a linear line there. So, linear trend might be visible there. So, overall trend would capture that change in the series from one period to next year. So, next period. So, that means year on year how the series has been changing, what has been the trend, whether the trend has been linear, it could be polynomial, it could be exponential, it could be cubic. So, if whether there is any structure in the way the series is changing, so that is something that we identify as trend. So, there are few more components, for example, seasonality and noise. So, we will talk about them in the next lecture. So, with this we will stop here. Thank you.